Hi, we are Marta, Chiara and Eleonora, three biomedical engineering students from Politecnico di Milano, and we are developing our project BRAINQUBE at NextLab. To every person who missed our first presentation, BRAINQUBE focuses on the neuroscience field, and in particular our goal is to accelerate the analysis of fMRI data that leads to the recognition of resting state brain networks. In this presentation, I'm going to introduce you the work organization. Our work is composed by three main steps. The first is the state-of-art and related works analysis. The second is implementation, and the last but not the least, the final evaluation. The first step is the identification of the problem focus. This is allowed by the study of the resting state brain connectivity context, which includes operating principle, its benefit and innovation in scientific field. After this, it is necessary to individuate the best algorithm for the identification of resting state networks present in the state-of-art. In literature, there are many options such as principal component analysis and blind search separation algorithm. Our team, considering the peculiarities of the resting state, chose the ICA, Independent Component Analysis, a particular type of blind search separation algorithm. The second step is the implementation of the algorithm in three different levels. They gradually increase in complexity both for the language and the structure. At the beginning, we start with a combined implementation on MATLAB. That is a combined implementation of software and GPU. This step allows us to understand the real complexity of the code structure and to verify the proper functioning of the code, measuring the performances of poor implementation against already existing MATLAB tool. After that, we translate the code in C language that, even if is worse in terms of performances and more difficult in terms of writing than MATLAB, is indispensable and preliminary for hardware implementation. Finally, we move part of our algorithm on FPGA board in order to obtain better performances in terms of energy consumption and velocity. The third step is the final evaluation. In each implementation, we have already tested the results, but at this point we have to understand their meaning, verify if our expectations are satisfied, and check the accuracy of final results. Here you can see an overview of our work organization from April to the end of June. You can see the main steps already mentioned with a color and time course. Problem definition in red, implementation in orange, evaluation in yellow, and writing in green. In addition, there are the milestones that are the main important deadlines that we have to respect, such as the end of hardware implementation and the submission of Xilinx Open Hardware Contest 2017. Through the analysis of the market, we identify the strengths, weaknesses, opportunities and threats of our project. The unique features of BRAINQUBE are the low cost of the tool, which will be totally free, even in terms of time and energy consumption. A simplification of the analysis process will make it available to a wider range of people involved in brain networks research, which is a rising field. The drawback of having implemented only one algorithm for resting state analysis, the ICA, and as a consequence of having a less complete tool than those used nowadays, and a very simple graphical representation of the results, is not critical, since our algorithm is useful in a first phase of the study to test quickly some hypotheses without investing many resources. Finally, our knowledge in the biomedical field is supported by the technical skills of the other students and professors of the NextLab, making the team competitive both in the research context and in the practical implementation. Thank you for your attention. Feel free to write us if you have any questions, and be sure you don't miss any update following us on Facebook, Twitter and SlideShare pages. For more video explaining our project, check the Next Lab channel on YouTube.